Okay, a combination and a sequential circuit. So generally digital circuits, logic circuits for digital systems may be defined as a combinational or a sequential. Okay, so whenever I take a logical circuit, so they can be defined as two kinds of circuits here. So they are combinational or a sequential. So coming to the combination circuit, so the combination circuits will be like this. Okay, so any logic circuits will be of two kinds here. So logic circuits can be two ways here. So they are defined like this. So logic circuits can be combinational one, second one is a sequential. Okay, so coming to the combination circuits. Okay, so the combination circuits, the output is dependent only on the inputs here. Okay, so we'll take combination circuits. Those outputs will be dependent on only whatever inputs we give, so it is dependent on those inputs only. Okay, so in a sequential circuits, the output is only doesn't depend on the present state of inputs, but also the past history of the inputs matters in case of the sequential circuits. Okay, so as we already seen there. Okay, so the combination circuits and the sequential circuits. So what we have seen, so we have seen the differences between the combinational and the sequential. 1 minute recording. Yeah. Okay, so I've seen the differences between the combination and the sequential. So 1 minute. You can check here. So is it visible?
Yes, sir.
Okay. So this circuit, the combination circuit, the output is determined by the present value of the inputs only. So whatever the inputs will be giving, so that will be the output here. Based on the inputs only, we'll get the outputs here. So in case of sequential circuits, the output depends upon the present inputs and also the past history of the inputs. So whatever the inputs we give and whatever the previous inputs we gave, so those inputs are also responsible for the present output here. Okay, so present value of inputs and also the past value of the outputs are also responsible for the getting the output here, getting the present output here. Okay, so coming to the combination circuit, so we don't need any kind of memory here, so it doesn't have any memory. And coming to this sequential circuit, so we need a memory and a feedback path from output to the input. So why we need memory? So when we talk about the past here, so when we talk about the past, so past is nothing but it is related to the memory. So if I want to remember the past, so we need some memory, right? So if I forget whatever happened yesterday, so then I can say that I have no memory, right? So in the same way, so if we are talking about the past year, so definitely the memory plays an important role. The memory plays an important role. In the similar way, the combination circuit, so its output depends only on the present inputs what you are giving. Okay, and in case of the sequential circuits, it depends upon the present inputs and also the past history of the inputs is also essential here in case of the sequential circuits. Okay, so why we need memory here? Because it has to store the past history, so we need the memory in case of the sequential circuits. Whereas in case of the combination circuits, we don't need any kind of memory here because there is no need to store the past history of the inputs here. Okay, and a feedback path is essential in the case of the sequential circuit. So how to identify a combination circuit and a sequential circuit in the sense? So in case of the sequential circuit, so we'll get a feedback path. So we'll have a feedback path in case of the sequential circuit. So what is the meaning of feedback path here? So the passage from the output to the input here. Okay, so we'll be having a path here from output to the input. So in case of the sequential circuit, so we don't have such kind of path in case of the combination circuits here. Okay, and so coming to this complexity here, so the complexity levels in case of sequential circuit is more here. Okay, whereas the complexity levels in case of the combination circuit is less. They are simpler. Okay, they are simpler than that of the circuits here. Okay, and coming to this one here, so we will generally describe this combination circuits with the help of the truth table. Okay, so truth table in the sense we just will put the inputs and we'll get the outputs. Okay, so just inputs will be taken and output will be noted based on the inputs here or function of the logic gates or some other circuits here. Whereas in case of sequential circuits, so we need a truth table and also a timing diagram, or we will be having some state diagrams. So we have to describe that with the help of the truth tables and also the timing diagrams or state diagrams. Okay, and coming to this one combination circuit, so we don't have a clock signal here. Whereas in sequential circuit, so sequential circuits is again of two kinds here. So those two kinds, so one needs the clock, another doesn't need the clock here. Okay, so clock signal. So what is meaning of clock signal? Clock signal here. The clock signal is nothing but the train of pulses. So we'll be having train of pulses. The pulses in the sense like ones and zeros will be there. Okay, the ones and zeros pulses will be there. So those pulses are given. So to any kind of circuit. So in combination circuit, we don't use those pulses here. Okay, so whenever I say that I'm using a clock signal, so each and every operation is synchronized with the clock signal. For example, if I say that you're having a timetable, right? So timetable, if the classes are taken according to the timetable, so what we can say that all your classwork is synchronized with the timetable. Okay, is synchronized with the timetable. So the meaning of this is, so for this time, so 9:20 to 10:10, so the first hour will take place. I mean, based on the timetable, so that specific event will happen. For example, 9:20 to 10:10, so the class is M3. Okay, so the maths class will be taken from 10:10 to 11. So LS class will be taken. So it is synchronized with the timetable. So it is synchronized with the time here. So in a similar way, so we'll be having a clock signal. So each and every operation of a circuit will be synchronized with the clock. So only at the specific period of time, okay, so that event will occur here. That event will occur. So in other cases, the event will not occur. The event will, I mean, the other event may occur. So there are two possibilities here. So this event or that event. So it depends here. Okay, so just an analogy drawn between the timetable and your clock signal. So the clock signal is a signal, I mean, which consists of train of pulses here. So the pulses in the sense which has ones and zeros, highs and lows here. Okay, so that is given to a circuit and operations are depending on these clock signals here. Okay, in case of combination circuits, we don't have any clock signals here. Okay, we don't have any clock signals. Right, so that is the thing here. Okay, so the main differences are, so the output is only dependent upon the present value of its input only, and output is dependent upon the present value of inputs as well as the past value of the outputs here. I mean, we are giving the feedback, right? So those past values of outputs are also essential here. Okay, and it doesn't have a memory in case of the combination circuit. It has a memory. It should have a memory and a feedback path. Okay, so this, it doesn't have a memory, it doesn't have a feedback path from output to the input. Okay, and it doesn't have a clock signal. It may or may not have a clock signal. Okay, and circuit is simpler here. So this is a complex one, and its basic building blocks are the gates here, logic gates. Okay, and here we use the circuits called as the memory elements, which are called as the flip flops. So flip flops are the main uh, things here. Flip flops are the main building blocks of the sequential circuits here. Okay, so that is the major differences here, the major definitions of this one here. So this will be a combination circuit. So this, we can see the circuits here. The combination circuits will give the inputs and will take the outputs here. So inputs will be taken, inputs will be given to the combination circuit and we'll get the outputs here. Okay, so whereas in case of sequential circuit, so what we'll get here is, so will be included with the memory. So the memory will be included in the case of the sequential circuits. I'll show 1 minute. Yeah. So which includes the combination circuits plus the, in the feedback path we are using the memory elements here. Okay, in the feedback path we are using the memory elements. So you can see the difference, right? Okay, so earlier it was the combination circuits alone, so where the inputs are given and outputs are taken, whereas in case of the sequential circuit, so we are using a memory element. So those memory elements are nothing but the flip flops here. So those memory elements are using the feedback path from the output to the input here. So here the output is given to the memory element and that memory elements are given as input to the combination circuits here. So this is the feedback path here. So from output to the input here. You getting my point?
Yes, sir.
Yeah. So any note, let me know. So you know, because this is the basic thing here. So the combination circuits and the sequential circuit. So any doubts in this definition? So definition differences. Any doubts in Kevana? So we'll go to the concepts here. So we'll start with the design of this combination circuits. So any nodes? No nodes, right? So please respond.
No, sir.
Okay. Oh, so we'll straight away start with the combination circuits and the design of the simpler circuits. Okay. So we'll design a simple circuit here. We'll start with the adders here. Okay. So we'll start with the combination circuits which will perform the add operation or so what are the operations? We'll see that. Right. 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 We'll start with the combination circuits and the design of the combination circuits. So first we'll start with the adders. What kind of adders we'll decide here. So first of all, we'll see the half adder and full adder. Please note that. So note this. So half adder and the full adder. Okay. So coming to the half adder. So design of half adder. The design of half adder will be like this. So generally half adder means so it will add so half adder will add 2 bits. Okay, so half adder is mean to add 2 binary inputs. So or I can say that to add 2 binary inputs. Okay, and it will generate 2 binary outputs. Okay, so this is a half adder. So generally half adder will add 2 binary inputs and it will generate 2 binary outputs here. So we'll draw a block diagram for this. The block diagram will be like this. So this is the half adder. Okay, so with 2 inputs, I'll say it as XY, and 2 outputs, I'll say it as S and C. Okay, so this is 2 inputs XY, and this is two outputs sum and carry. Okay, so this is the block diagram of half adder here. Okay, this is the block diagram of the half adder. Okay, so it will generate two outputs here, so with two inputs x and y. So now I have to draw the truth table here. So for any design, so this is the common thing here. So if you are given a circuit like this, so you design a half adder and full adder. So first of all, define those terms here. So it is used to add two binary numbers, okay, and it will generate two binary outputs here. Okay, so now I'll go for the truth table here. Okay, so the truth table will be like this. Okay, so two inputs will be having two inputs here. Two inputs. What are two inputs here? So x, y, and two outputs sum and carry. Okay, so two inputs will be having four combinations. So 0, 0, 0, 1. So 1, 0, 1, 1. Okay, so these are the four combinations here. So generally what we'll get here, so when I add 0 plus 0, what is 0? What is 0 plus 0? It's a 0. And we don't need a carry. I mean, so additional carry em radinto. So 0, 0, sum is 0, carry is 0. So 0 plus 1, sum is 1, carry is 0. So 1 plus 0, sum is 1, so carry is 0. So when I add 1 plus 1, okay, so when I add 1 plus 1, so what happens here is, so we'll get a 1 as this, I mean, we'll get a 0 as, so generally 1 plus 1 is 2, right? So 1 plus 1 is 2. So 2 in case of binary, it emotionally. So what happens in case of binary? What is 2 in binary?
Sum is 0, carry is equal to 1.
So carry is equal to 1. I mean, in the sense, so 0, 0, 8421 codes is 0, 0, 0, 0 is 0, 0, 0, 0, 1, 0, 0, 1, 0 is 2. So 1, 0 is 2, right? So 1, 0 in the sense, so 0 is sum here, so 1 is carry. So 1 is carry. Okay. So 1 plus 1 is sum is 0 and carry is 1. So it will be carry forward to the next state here. I mean, so whenever I have the next circuit, so it will be carry forward to the next state here. So the carry will be 1 in case of the when x is equal to y and x is equal to 1 and y is equal to 1, sum will be equal to 0 and carry will be equal to 1. Okay, so that is the case here. And if I write the equations for this, okay, so equations LRILE, so we'll check the truth table here. So when I check the truth table, so I had to add the min terms, so which are making the values of the truth table as 1 here. Okay, so S is equal to 1 1 ekkadundi manaku. So for this input combinations, so for this input combinations, the value of S is equal to 1 here. So this is this one and this one. So the value of S is equal to 1 and C is equal to 1 for these combinations. So S value can be written as, so let I write S value on it. Can I write the S value? X bar Y plus XY bar. Yes or no?
Yes, sir.
Is equal to XY. I think you are prepared for that exam, right? So I given all the problems which are solved by which are solved in the class only. Okay. So here the value of S will be equal to, I mean the value of S is taken as 1. Okay. So I mean the input combinations which are making the value of S as 1, so are included in the final output here, or included in the final output. So S is equal to 1 undi kabatti I am taking these input combinations. So S is equal to 1 undi kabatti I am taking these input combinations. So XY bar plus X bar Y bar. Okay, and this is C is equal to 1 only for this combination. Okay, so C is equal to 1 only for this combination. So what is this combination here? So C is equal to XY here. Clear?
Yes, sir. Yes, sir.
Okay, so now I have to draw the logic diagram here. I have to draw the circuit here. Okay, so using logic gates. So using logic gates, I had to draw the logic circuit for the half adder. Okay, so what are the equations here? S is equal to X Y bar plus X bar Y. So C is equal to xy here. Okay, so I draw the logic circuit here. So what happens if I want to draw the logic circuit here? So this is the case here. Right, so S is equal to x bar y plus xy bar. So this is, so x bar y, so x bar into y, which is given to AND gate here. So this is x bar and this is y. Okay, this is given to AND gate. Another one is x y bar. This is given to another AND gate, and both are given to this addition. So addition in the sense it is given to OR gate. So addition is given to OR gate. So you know the symbols, right? So I can draw this. I can't draw this clearly. So this is S here, and carry is equal to xy. So x, this is x here, and this is y. Okay, so this is AND gate. It is given to AND gate. This is carry. Clear?
Yes,
Yes,
sir.
sir.
Okay, and what we can do here is, so we can implement this with the help of XOR gate also, right? So this is x bar y plus xy bar. So this is XOR gate symbol, right? So XOR gate function, right? So we can implement with the help of the XOR gate also. So what I can do here is, so this is another one here. This is xy. I'll be giving the inputs here. If I give it to XOR gate, so sum will be is equal to xy bar plus x bar y. Okay, so sum is equal to xy bar plus x bar. So what I can write here is, so this is x XOR symbol of y. Okay, so x XOR symbol of y. Clear? And this one is xy. This is x here, and this is y. So this is carry. So C is equal to xy, and sum is equal to x exclusive of y. So this is another diagram for half adder. Okay, this is another diagram for the half adder. So this is one diagram, and this is another diagram. Clear?
Yes, sir.
Yeah, sir.
So this is the block diagram, this is the truth table, and this is one logic diagram, this is another logic diagram.
Sir, someone are waiting to join, sir.
Yeah. Done? Yeah, if anyone, please let me know, because there may be a network issue, or these online modes will be like this only. Right? So this is the half adder here, so next we'll go for the full adder. Okay, we'll design the full adder. Control. Full adder circuit is a combination circuit that performs arithmetic sum of 3 bits. So half adder is addition of 2 bits here. So full adder is, it is a combination circuit which performs arithmetic sum of 3 bits. Okay? Or it will add 3 binary bits. So 3 inputs here, and it will generate 2 outputs only. Okay, so here we'll be taking 3 inputs here. Okay, so here we'll be taking 3 inputs. Okay, and we'll get 2 outputs here. Okay, the block diagram will be like this. Take the block diagram. So full adder. Three inputs. So X, Y are common. And one is the third output, so which may be called as input carry, or so I'll call it as Z simply. This is and 2 outputs. This is X, Y, Z. This is sum and this is carry. Okay. Now I have to draw the truth table here. Okay. Now we'll go for finding the truth table. Right. So coming to the truth table here. So first of all, we need 3 inputs and 2 outputs here. Three inputs X, Y, Z, and 2 outputs carry and sum. So or sum and carry. So whatever. Okay. So 3 inputs combination is a 0, 0, 0, 0, 0. So 1 minute. X, Y, Z. So this is carry and this is sum. One minute. Right. 0, 0, 0, 0, 0, 1. So write all the 7 combinations, 8 combinations. 0, 1, 0, 0, 1, 1. So 1,
0, 0.
0, 1, 0, 1. Okay, so 1,
1,
0,
0,
and 1, 1.
1.
1.
So for this input combinations, for 3 input combinations, so for 3, we'll get this input combinations here. Okay. So what we know here is, so for these combinations, we'll get this input here. Yes or no?
Yes, sir.
Okay. And we have to write the sum and carry. So just add 3 bits here. So 0 plus 0 plus 0, it's a 0. So sum is 0, carry is 0. Okay. So 0, 0, 1, this carry is 0 and sum is 1. Okay. So carry is 0 and sum is 1. And 0, 1, 0, same way. So 1 unnappudu, so carry is always 0. Sum is 1. And 0, 1, 1. So carry is 1, sum is 0. Because you know the 0 plus 1 it is 1, 1 plus 1 it is carry is 1 and sum is 0. And here we have a single 1. So single 1 only gavatti sum is 1, carry is 0. When you had 2 ones, so carry is 0. Sorry, carry is 1. When we have 2 ones, sum is 0. So when we have 2 ones, the carry is 1 and sum is 0.
0.
Okay, and the last one is 110. So we have 3 ones here. Okay. So what happens here? So when I add a 1 here, so I'll get a carry of 1 and sum of 0. Okay. So some marine ko 1 add just same out. So 2 ke 1 add just same out. So if I add 1 plus 1, it is 2, and 2 plus 1, it is 3. So what is 3 in case of binary? So binary 3 most 8 4 3 1 4 lo. So what is the binary value?
1 1, sir.
1 1.
So it is 1 1. So 3 is equal to 1 1, right? So 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1. Okay. So then sum will be equal to 1 and carry will be equal to 1 here. When it is triple 1. A simple case, right? So previous one ain't. So 1 1 0 on this. So 1 1 0 came out 1 0 వచ్చింది. So carry is 1 and sum is 0. Okay. If I add 1 to this, so 1 0 1 add just ఏమవుతుంది? So 1 0 1 add చేస్తే we'll get a 1 1. Okay. So if I add a 1 0, I mean 1 to this 1 0. Okay. So 1 to this 1 0. So what I'll get here is, so I'll get a 1 1 here. So this is carry and this is sum. Okay. This is carry and this is sum. Okay. Now tell me the combinations here. Tell me the combinations. Okay. And so tell me the values of S. Tell me the value of C. Tell me the value of S and tell me the value of C here. So what is the value of C? What is the value of C?
X bar y z.
C is where C's are equal to 1 here. So C చూడండి ఇక్కడ
Dash y z.
Huh?
0 1 1
X dash y z, sir.
X
X bar y z, sir. Y z
yeah plus
plus x y bar z.
X Y bar Z
Z plus x y z bar.
X Y Z bar
Z bar plus x y z.
X Y Z. Okay. So this is this expression for carry here, and for sum,
X bar y bar z.
X bar y bar z.
X bar Y bar Z
Plus x bar
X
y z bar.
bar Y Z bar
X bar y z.
X bar Y Z. So where is
X y bar z bar, sir.
yeah X Y bar Z bar
Plus x y
plus
z.
X Y. So we can do like this, but what we'll do here is we'll perform some K-map functions here, because you know this is a complex one, a little bit complex one. Okay, so what we can do, we can perform the K-map operation here. Okay, so for what we can do here is, for summon carry, we'll perform the K-map operation. I'll tell you a logic. Okay, so I'll tell you a simplified logic for calculating the sum of this. So sum ki easy ga cheyochu. So carry ki will perform a simplification. Okay, first of all we start with the carry here, so which is a 3 variable K map. Okay, 3 variable K map, we can do this. So please mute yourself. Answer చెప్పిన తర్వాత mute చేసుకోండి. If there is no disturbance, fine, but if there is disturbance, please mute. Okay, so now what we can do here is we'll draw a K map here for carry and sum also. First of all, we do it for a carry here. It is XYZ, so it is 0 0 0 1 1 1 0 0. is 0. This is 1. And the things are like this is x and this is yz. Okay, so for carry it is like Japan. So what are the values here? So what are the min terms here? So min terms are nothing but this is m naught. I'm letting you know the min terms here, m1,
M3, M2.
3, and this is m2, and this is m4,
M5, M7, M6.
m7, m6. Yeah. Okay. So tell me the min terms for carry here. So I'm talking about carry. So what are the min terms for carry? So carry k min terms unnai manaki ikkada. So carry is min terms are like 0, 1, 1. So what is 0, 1, 1?
M3, sir.
1, 1, and so 1, 0, 1. So this is the thing here, and 1, 1, 0, and 1, 1, 1. So this is 0, 1, 2, 3. This is m3, m5, m6, m7. Ante kada. Okay. So m3, m5, m6, m7. Yes or no?
Yes, sir.
Okay. So these things, now we have to perform the K map here. So what I can do here is, so I can form 3 pairs here. So this is 1 pair, second pair, and this is the third pair. So 3 pairs, right? Yes or no? This is a simple one. Already we discussed about 4 variable K maps. This is the simple one. Okay. So what is the first pair here? So I'll use a different color. Okay. So this is the first pair. So M5 and M7, and this is the second pair, and this is the third one. Okay. So E two combinations ఏం వస్తాయి మనకు ఇక్కడే చెప్పండి మీరు. So pairing these two. So pairing these two, what I'll get here is, so x value is 1 here. I mean x is equal to x, we have the row value as x here. Okay. And what is the column value? So grouping these two. So grouping these two lo ఏది కామన్ ఉంది మనకు?
Z, sir.
So this is
Z,
common.
sir.
YZ, sir.
This is xz. Okay. And these two, this two.
YZ.
So we don't have a row term here
YZ.
because
YZ.
all the groups are selected here. So only it is equal to xz. So yz plus, and these two. So these two.
XY.
This two, it is nothing but this is x we have here already. Okay. And sorry, this is not 0, 0. This is
1, 0, sir.
1, 0. Sorry. Okay. And it is
XY, sir.
XY, sir.
it is equal to xy. So C is equal to simplified version of carry is equal to xz plus yz plus xy. Okay, xz plus yz plus xy. Clear?
Yes, sir.
Okay. So I'll tell you a shortcut for this sum here. Okay. So in case of half adder, so what is the output? So half adder lo output em ochindi manaku? So half adder sum output em ochindi? So what is output of sum in case of half adder? So what is output?
X bar Y plus
X bar Y plus Y, X Y bar, sir.
That is equal to nothing but x exclusive of y, right?
X bar Y.
Okay. So if I if I take a truth table of the previous one, if I draw the K map for this, so in case of the previous one, so sum ki truth table is there. This is x and this is y. Okay, and this is 0, this is 1, and this is 0, and this is 1. So check the truth table of half adder. So truth table is the most in Japan. So what are the min terms? So what are the min terms? So tell me the min terms for sum in case of the half adder. So half adder k midterms ఉన్నాయి. It is nothing but x is equal to 0, y is 0, 1, 1, 0, right? That is
0,
this
1,
m naught,
0, 1, 0, sir.
m naught, m1, m2,
M3.
m3. So the midterms are nothing but m1 and m2. Okay. So m1, m2. In case of the sum, in case of the previous half adder లో అయితే k map తీసుకుంటే ఇట్లా వస్తుంది మనకు. అవునా కదా?
sir.
Okay. So so there is no pair here. So just we have to take the individual terms here. We have to take the individual terms. Okay. And see the min terms here. So m1 and enti. So what is meaning of m1? So what is m1? I can write it as
X bar Y.
X, Y bar.
that is x bar y, that is 0, 1. And in case of this one, m2, 1, 0. Yes or no?
Yes,
Sir.
sir.
Okay. And it has odd number of ones. It has odd number of ones. This m1 and m2 has odd number of ones. Getting my point? So you just understand this. Okay, it has odd number of ones. So whereas the previous one, m naught and nt 0, 0, and what is m3? It is 1, 1. So it has even number of ones and it don't have ones here. So we'll consider it as even only. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. So so this exclude your gate is used to implement the odd function. Okay. So x is equal to x bar y plus x y bar వస్తుంది. That is equal to exclude your gate అన్నాను. And if I take a k map here, so the k map has the ones in m1 and m2 here. So m1 and m2 is having a 1, and this output is equal to x exclusive of y. So the meaning of this is, so exclusive gate is used to implement the odd function. So the meaning of odd function is the min terms contains the odd number of ones. The min term contains the odd number of ones here. So getting my point?
Yes, sir.
Okay. So we have the exclusive OR gate. So where the exclusive OR gate is used to implement the odd functions. They are used to implement the odd functions. Okay. So I mean, if I go on expanding this, so the things also Yeah. Am I audible?
Yes, sir.
Yes, sir.
What happened? The break in. Eక్కడ break in? Maybe then a tissue. So, can you see my screen?
Yes,
Yes,
sir.
sir. Sir.
Yeah. సో ఎక్కడ స్టాప్ అయింది మనకి ఇక్కడ సో ఇక్కడ మిన్ టర్మ్స్ రాసిన వరకు వచ్చిందా
No, sir.
సో where did I stop like so this is the min terms for sum clear it's already carry చేసాం కదా so in a similar way okay so there is a min terms for sum so sum చూడండి ఒకసారి so see the two table for sum here okay so what are the min terms that are to be included in the final sum this is you check here
M1,
this is
M2,
m1
M2.
and this is m2 this is m4 this is m7 right so please respond I can understand whether you are following or not
Yes, sir.
Yes, sir.
okay this is m1 m2 this is m4 and m7 clear
Yes,
okay so there is no grouping possible here so m1 m2 m7 and m4 so and check this min terms here so what is the min term m1 is 0 0 1 so m2 is 0 1 0 so m4 is 1 0 0 m7 is 1 1 1 so what is the similarity between all these four
Odd number of ones.
yeah it has odd number of ones okay so check the other terms here so m0 so it is 0 0 0 so m3 it is 0 1 1 and m6 it is 1 1 0 m5 it is 1 0 1 so all the remaining things will have even number of ones okay it has even number of ones so hence this can be implemented with the exclusive OR gate so exclusive OR gate is nothing but so exclusive OR gate is meant for implementing the OR function so this can be implemented with the help of the exclusive OR gate so instead of writing all these equation so the simplify chesina kuda manaku vachedi ade okay if I simplify it also I can get this equation like x exclusive OR of so y exclusive OR of z okay because this k map so this is the function here okay so I can simply write it as s is equal to exclusive OR of y exclusive OR of z so these are the simplified expressions here this is sum here okay and this is carry here for full adder so note down these equations so note on the equations clear
Yes,
Yes,
sir.
sir.
yeah so I need a logic diagram here so what I can do just draw the logic diagrams so మీరు ఇట్లా కూడా డ్రా చేయొచ్చు అంటే ఇంప్లిమెంటేషన్ ఆఫ్ దిస్ వన్ లైక్ సో ఇలా డ్రా చేయొచ్చు లైక్ యూజ్ ద అండ్ గేట్స్ హియర్ సో ఎలా డ్రా చేస్తారంటే వెయిట్ ఐల్ షో సో why to waste the time yeah so I can draw the diagram like this okay for this is for sum so this is the lengthier one okay so this is sum and this is carry here okay so c is equal to xy plus xz plus yz or else you can directly what you can do just use the exclusive OR gate so exclusive OR gate in the sense so x exclusive OR of y exclusive OR of z right so that I can write it as x This is x exclusive or of y, and the output is given to another XOR gate here, and this is Z. This is given to XOR gate. Write the XOR gate symbol, and this is x exclusive or of, so y exclusive or of Z. Okay, so this is logic diagram for sum here, and this is for carry. So carry can directly implement with the help of this one. This is logic diagram for the carry. Or else complex one line parledu ante you can write like this. Clear?
Yes, sir.
Yeah. So clear with this full adder?
Yeah, sir.
Let me know lateral entry malunnaru. So let me know those lateral entry people. Please let me know. So any doubts in this? So any lateral entry people join. I don't know the names. I know one or two. I think. You're join here, huh? So are you following?
Yes, sir.
Yes, sir.
So please let me know. So you might have college from 1st of February. Okay, so we'll repeat the classes also. Okay.
Okay, sir.
No, it is like we'll take some additional classes also. So apart from so what we'll do here is we'll be having, I think, I mean, I am not stopping the class. Please don't drop that way. Right? The class continue చేస్తాను. So you don't worry about the timings. So when I said leave, and we can leave, right? Uh, so what we can do, we'll be having 1 month of time. So what we can do, we will take the online and offline classes also, even after coming to the college, right? So college వచ్చిన తర్వాత ఆన్లైన్ అండ్ ఆఫ్లైన్ రెండు తీసుకుందాం, because the time doesn't permit for only the offline classes. We'll take both online and offline classes when the college starts, right? And so what we have seen here, so the implementation of 1 minute. Vasu? Right, now take this diagram, implementation of full adder using 2 half adders. So this will be one more question here. Okay, so implementation of full adder using 2 half adders. So take this diagram. So this is the first half adder, and this is the second half adder, and this is OR gate. So implementation of full adder using two half adders. So this may be one of the questions here. Clear? So this is a diagram here. So this is a diagram. So this is how we have to implement a full adder using two half adders. So the carry will be the different one here. So we'll get different equation, but the output will be the same here. The output is same. For some it is fine. So x exclusive of y exclusive of. So x is equal to x exclusive of y exclusive of z. So this is fine in case of the sum here, but in case of carry, we'll get this equation. So this is the equation for carry in case of the implementation of full adder using two half adders and OR gate. So this is the equation for sum, and this is the equation for carry for this kind of implementation. Clear?
Yeah, sir.
Yeah. So take this diagram. So this is also important. Sometimes you'll be asked for implement a full adder using two half adders and OR gate. So you'll get this kind of question also. And this is the equation for sum, and this is the equation for carry. So carry is equal to x exclusive of y into z plus xy. You may expand this also. Clear? Yeah, I think no class is scheduled, right? So the next class MBA kada inka. So if there is no class, I'll continue. So continue for 20 minutes.
No class.
Yeah. So you can take 2 to 3 minutes break. So we'll continue with the next topic called as half subtractor and full subtractor. Done? Yeah. So check this. Half subtractor, the opposite of addition is subtraction. So we'll be having two subtractors here. So half subtractor and full subtractor. So 2-bit subtraction is called as half subtraction, and 3-bit subtraction is called as the full subtractor. So it is used to implement the 3-bit subtraction. It is called as the full subtractor, and we'll be having two inputs and two outputs. In case of the half subtractor, two inputs xy and two outputs, that is difference and borrow. So earlier it was carry and sum. So sum is nothing but we are performing addition, so hence it is called as a sum here. So we are performing the difference here, since it is called as the difference here. So it is indicated as difference here. So generally subtraction law will call it as a borrow. So in sum we'll call it as a carry. Okay. So hence I mentioned it as borrow here. Okay. So for example, if I say that 0 minus 1, so then definitely borrow this call. So hence the borrow will be equal to 1 there. Okay, so check this truth table here. So x is equal to y is equal to 0, 0 and up to. So 0 minus 0. So what is output here? So difference is 0, borrow is 0. 0 minus 0. Okay, so 0 minus 1. So what is 0 minus 1? So what is borrow and what is difference?
Borrow 1, difference 0.
Borrow 1 and difference 0. No? Sorry. 0 minus 1. So what I'll need here is, I'll definitely need a borrow, but so difference is also equal to 1 here. So when I get odd number of ones, so difference is equal to 1 and borrow is equal to 1. So there's simple technique what I have to remember here. Okay, so 0, 0, 1. 0, 0, 1. So what I have to do here is 0 minus 1, I am subtracting definitely I need a borrow here. Okay, so I need a borrow. So definitely I need a borrow here because I'm subtracting 0 minus 1. Okay, so and if I subtract 0 from 1, so what happens here is obviously there is also difference is also equal to 1 here. Okay, difference is also equal to 1. Okay, remember this. So when 0 minus 1 here, so x minus 1, 0 minus 1, so difference is equal to 1 and borrow is equal to 1. Okay, difference is equal to 1 and borrow is equal to 1. And 1 minus 0, so there is no need of borrow here, hence difference is 1 and borrow is 0. Okay, so 1, 1, so both are zeros. So difference is 0 and borrow is 0. Okay, so don't get confused here. Okay, so it is difference is 0 and borrow is, sorry, difference is 1 and borrow is 1. Okay, so equations are like this. So the equations are for D. So what is the equation for D here? So D ki E2 equations untai. So this 2. So this 2 for difference and borrow only this one. Okay, so it is x bar y plus xy bar. The same one, like x exclusive of y. Case of Greenlaga. So borrow
X bar Y.
y. Okay, so draw the equation. Circuits for this. So difference borrow key equations. Circuit drawing. So borrow is, so difference is x bar y plus xy bar. So the same as earlier kind. So this is difference and borrow is x bar y. This is borrow. Okay, and if I want to implement with the help of exclusive OR gate, it will be like this. So exclusive OR of y. And the borrow is x bar y. So I'll use an inverter here. This is B and this is D. Sorry. This is D and this is borrow, different than borrow. So same exclusive OR gate, but inverter uses some x bar y. Clear?
Yes, sir.
Okay, and this is the truth table, and these are the equations, and these are the logic diagrams for half subtractor. Next, we'll go for the full subtractor. Full subtractor. So it is a 3-input block diagram is 3 inputs. So full subtractor. So 3 inputs. And 2 outputs. So x, y, z. X, y, z. And the same thing, difference will be have a borrow here, and we will be having the truth table will be like this. So x, y, z, difference and borrow. So 0, 0, 0, 0, 0, 1. So 0, 1, 0, 0, 1, 1. So 1, 0, 0. So 1, 0, 1. So 1, 1, 0, 1, 1. Okay, and for 0, 0, 0, so difference is 0, borrow is 0, fine. So 0, 0, 1 ante 0 minus 0 it is 0, 0 minus 1 it is the difference is 1 and borrow is 1. Okay, and 0 minus 1 emotundi ante, so 0 minus 1 it's obviously so ఇక్కడ చూడండి ఒకసారి, so 0 minus 1, so already in case of half subtractor what we got is difference is 1 and borrow is 1. Okay, so earlier case you can check this case here. So 0 minus 1, so in case of half subtractor, so difference is 1 and borrow is 1, and if I subtract 0 from this, so what, there is no, then there will not be no difference here. So 1, 1 again it is 1, 1. Okay, so getting my point?
Yes, sir.
Yes, sir.
0 minus 1 it is difference is 1, borrow is 1, and if I subtract 0 from that, there is no difference in difference is 1 and borrow is 1, so hence it is again 1, 1 here. Okay, and 0, 1, 1 it is 0 minus 1, so 0 minus 1 వస్తే ఏమొస్తుంది, so 0 minus 1, so what I'll get here, so difference is 1 and borrow is 1. Again if I subtract 1 from this, so what happens here, so I'll get a difference of 1 and borrow is 0. Sorry, difference of 0 and borrow is 1. Okay, this is 1 minute. 0 minus 1, I'll get a difference and borrow, so difference is 1 and borrow is 1. Okay, and if I subtract, so I have to subtract from difference here. Okay, so 0 minus 1, it is difference is 1 and borrow is 1, and I had to subtract minus 1, minus from difference here. So minus 1 is same avutundi. So difference is 0, borrow is 1. Okay, so difference is 0, borrow is 1. Clear? So please make sure. So if it is not clear, I'll so draw the table neatly. So simple thing, but you may get confused. Wait. So x, y, z. So difference borrow 0, 0, 0, 0, 0, 1, 0, 1, 0. Okay, so here difference is 0, borrow is 0. So obvious, this is obvious. And 0, 0, 1, 0 minus 0 is 0. And 0 minus 1 is difference is 1, borrow is 1. So we have seen in the half subtract also. And here in case of 0, 1, 0, so what happens here is 0 minus 1 is difference is 1 and borrow is 1. So general ga 0 minus 1 cheste. So difference em vastundi, borrow em vastundi. Okay, so generally difference is 1 and borrow is 1, and 0, 1, 0 ante again I have to subtract 0 from difference here. Okay, so if I subtract 0 from difference here, so 1 minus 0, it is 1, and borrow is 1, already 1 there. So and hence it is again 1 and 1. Okay, in case of next one, 0 minus 1, difference is 1 and borrow is 1, and again if I subtract 1 from difference here, so what I will get here? So 1 minus 1, it is 0. Okay, and it is 0 and 1. Okay, it's 1 minus 0, difference is 1 and borrow is 0. Because 1 minus 0 is 1, there is no need of borrow, and again minus 0, it's no difference here. Okay, and here you can check here. So 1, 0, 1.
0, 0, sir.
Yeah, it is 0, 0. Okay, so 1, 1, 0 is also equal to
0, 0.
0, 0. Okay, so 1, 1,
Next
1.
1, 1. 1, 1.
Yeah, so 1, 1, it is 1 minus 1, it is 0. 0 minus 1, it is 1, 1. Difference is 0, borrow is 1. Okay, now take the K maps for D and B. So take the K maps for D and B. So check the D here. So ఒకసారి D check చేయండి. సో రఫ్ గా చెక్ చేయండి ఒకసారి మీరు D ని. సో D కి ఏమేమి ఉన్నాయి ఇక్కడ మనకు?
M1, M2.
Yeah. So D, for D it is M1, this one,
M2.
M2,
M4.
M4,
M7.
M7.
Same in case like sum law lagane, we got this K map here. So this is odd function which can be implemented with the help of the exclusive OR gate, that is X exclusive OR of, so Y exclusive OR of Z. So that is difference, right? So if you want elaborated one, you can expand this min terms here, like M1 plus M2 plus M4 plus M7. Okay, in case of borrow, so draw the K map now. So borrow K map draw cheyandi. So K map will be like this. So what are the min terms here? So this is X, this is YZ, 0, 1, 0, 0, 0, 1, so 1, 0, 1, 1. Okay, so what are the K maps here for borrow? This is M0, M1, this is M0, this is M1, M2, M3, 4, 5, 6, 7. Okay, this is M1, M2, M3, and M7. So this one. So these two combinations. Okay. First of all, we'll check these two. Okay. So what is this two? This is X term is this row term is X bar into column term is these two column terms are grouped here. Okay. This is Z, X bar Z. Okay. And next these two. So this is equal to YZ. Sorry. X bar plus YZ. And this two. This X bar. X bar. So what is this term here? X bar Y. Law. ఇక్కడ కాదురా ఎస్కేవ్ కాదు అది. ఓకే 1 minute. Right? This is the equation for carry here. Okay, so what is the equation here? X bar Z plus YZ plus X bar Y. Clear?
Yes, sir.
Rho is equal to
Yes, sir.
X bar Z plus so YZ plus X bar Y. Okay, so these are the basic simple adders and subtractors. So we have some binary adders also, so decimal adders. So little bit complex, but it's okay. If we understand the architecture, that will be easy. But we'll see that later. Okay, next class we'll see what we'll see here is we'll check the other combination circuits. Okay, so we'll see the designs of the combination circuits. Okay, so then you'll understand. Last we'll see this decimal adders and all, multiplets and all. So those are architectural complications only, but understanding wise it's easy. But we'll see them in the last. Okay, there are many more important circuits also. So we'll see those circuits and we'll check the examples and we'll check all those things in the next class. So next class I don't know whether I'll be taking the evening session or tomorrow morning sessions for same time. Okay, so evening I may take it around 5:30 to 6:30. So 1 hour I'll be taking every day. Okay, so morning and evening I'll be taking. Clear? So
Okay, sir.
yeah,
Okay, sir.
yeah. So I'll send the recordings also by the end of the day.
Sir,
Yeah, చెప్పండి.
when will be the SEM exam, sir?
Some exams in the month of March, second week maybe.
Thank you, sir.
Yeah. So if we are confident and if people are prepared, then only we'll go for that SEM exams. Okay, so maybe half 1 week కానీ 10 days కానీ later అయినా పర్లేదు కానీ. So we'll see everything is at least 60 to 70% satisfied by you people. Right?
Okay, sir. Thank you.
Yeah. Thank you.
Thank you, sir.
Yeah. So definitely 99% I'll be taking the class in the evening session. I'll let you know.
Okay, sir.
Yeah.